Hello, welcome. This is Naveen Kabra, and this is the second session in my talk on the blockchain technology series. Today, I'm going to be talking about Bitcoin in particular and other cryptocurrencies in general. I would expect you to have already seen my previous talk, which was on blockchain, the technology. I will not be covering that again today, but I will give you a little bit of an overview so that people who have seen the previous talk, this will be a revision for them. People who have not seen the previous talk can hopefully follow based on this overview. So let me flip over to my slides. Okay, this is the second in my series of talk. First, we did blockchain. This time it is Bitcoin and other altcoins. Later on in the series, we are going to cover more advanced topics, and those will be of interest mainly to real enthusiasts. So we will do Ethereum and smart contracts and ICOs and permission blockchains and other such things. But the first two, blockchain and Bitcoin, are should be of general interest pretty much to everybody. So far, in my previous talk, I gave you an idea of what blockchain is. Basically, blockchain is an online system for tracking ownership of anything. I'm just going to call them objects for now, but it can be anything. You could be using it to keep track of properties, to keep track of expensive stamps, to keep track of gold, or to keep track of money, right? The ownership is protected by digital signatures. And I'm not going to get into the cryptography that is used in digital signatures, but for now, just assume that you understand that digital signatures can only be created by the owner of that particular object. Now, you can transfer ownership by adding a transaction onto this online database. So the owner of any particular object can say, I transfer ownership of this object to somebody else, and they can sign it using their digital signature. Right? Now, this collection of transactions, which is essentially transfers of ownership, this is what the blockchain is tracking, and this cannot be modified. There is clever technology being used here to ensure that nobody can change transactions once they have gone into the blockchain and sufficient time has passed. Now, to understand how this happens, you would have to see my talk on blockchain. I will not get into it today, but just trust me that it cannot be modified, right? And all of this is achieved without the use of any central server or without the use of government or a trusted third party, right? All of this is being done using a large number of servers in the cloud. And these servers together, they manage this database, this blockchain. Okay, now what is a transaction? Let us dig a little bit deeper into that. A transaction is transfer of ownership of an object which was being tracked by the blockchain from a current owner to a new owner. Now, a current owner just writes a transaction saying, I transfer ownership of so-and-so object to this new person. And this sentence, they sign it digitally. And now, because this person was the previous owner of that object and they have signed it digitally, now the ownership has been moved to the new person which is mentioned in this transaction, right? To do this, there is no need to log into any server. Anybody can submit a transaction, right? As long as it is signed by the current owner. So if I want to transfer ownership to Abhay, I can write up this transaction, and now the text of this transaction along with the digital signature of this transaction, this can be submitted by anybody. Bhushan could submit this to the blockchain, and it would be equally valid, because there is a guarantee that nobody other than me, the current owner, could have digitally signed this transaction. So the requirement that this should be initiated by me by logging into my account, or it needs to be submitted by me, is not there. The only thing needed is the digital signature, right? And you can submit this transaction to any server in the entire blockchain. And that server has the job of validating the transaction. What does it do? There are two things it needs to check. It needs to figure out who is the current owner of this particular object, and whether this signature is a valid signature of that owner. As long as these two things are taken care of, there is nothing else that needs to be checked. The transaction is valid and the ownership is transferred, right? This process, the way it happens, as far as Bitcoin is concerned, we need to understand one more thing, the concept of mining. So let me go quickly into that. Validating a transaction, which this random server in the network does, it's a very expensive affair for reasons that are specific to how a blockchain works. But the thing is that you do this validation for a whole block of transactions at one shot, right? A block will contain maybe 100, 150 transactions, and this block is together added to the blockchain in one shot. And this process is done by one particular server of the entire system. Of all the servers on the blockchain, one of them does this. This server is picked randomly by the system. The server which manages to add blocks, now it has been doing some expensive computation to add these transactions, right? This is called mining. And why will the server mine? Why is it spending so much electricity and CPU power to do this? The server needs some incentive, and for that there are two incentives in typical systems. One is that for each transaction that was included in this block, gets some commission, and then depending on the blockchain, for creating that block, that entire block, there is a block reward that the server gets, right? So this, in a nutshell, is a blockchain, and we are now going to see how to use this technology to implement a cryptocurrency. And then later on, I will get into specifics of what exactly is Bitcoin. Okay, let me just quickly check if there are any questions at this stage. All right. Any questions? All right. I'll assume that we are good, and I will move on. What we are going to talk about next is creating.
Naveen, there's one question. This is Abhay here. I have a question from Atul Thomre. It is not clear about how all the servers will have the same set of unconfirmed transactions. I think you covered it in the last session, but maybe he did not attend the last session. I will repeat the question. How all the servers will have same set of unconfirmed transactions?
Yeah, so I'm not going to spend too much time this time on blockchain related issues. The quick answer to this one is that the blocks are all chained, and every server needs to check the chain all the way back. And if their chain is broken, then they talk to another server and synchronize. So that pretty much ensures that there can be only one set of transactions. All right. So moving on to let's try to use this to create a particular cryptocurrency. All right. Okay. All right. So what I'm going to do is I'm going to create a Bhai coin. So we have a Bhai, and he has decided that he wants to create his own money, right? So in the last talk, I had given an example of land ownership being tracked by the blockchain. Instead, now going to keep track of the coins. So Bhai has created 10 million coins, or maybe it's 100 million, I don't know. And each of the coins is numbered, and every coin is individually tracked on this blockchain, right? The current owner is identified, and we use digital signatures to transfer ownership of these coins. Now, what are transactions in our system? Transactions are one or more coins being transferred from one person to another, and there can be commission while we are doing this. So essentially, every transaction on the blockchain is a money transfer. Okay. Now, initially, right in the beginning, when the system was created, all the coins belong to Bhai, right? And Bhai just gives it away to his friends. Initially, he gives them away free, and after a while, more and more people are interested in it, and they're, hey, even I want to try this out. This looks like an interesting thing. So soon, he's giving like pizza. He wants pizza in return for giving 10,000 coins, and after a while, he's charging, right? What is the idea behind Bhai coin? The idea is that this is currency, and Bhai has said that in his ilaka, in his area, people will accept this coin, and Bhai has guaranteed that anybody who uses these coins, and if they ever want real money in exchange for these coins, Bhai will refund this money to them. So very soon in his area, people, when they go to a kirana store and there is no change, the owner, instead of giving a chocolate, he pays Bhai coin to the customers, and now customers have extra Bhai coin which they give to their milkman, or they give as tips, and so on. After a while, Bhai coins are circulating in the system, and depending on how easy it is to use, pretty soon people find that using Bhai coin is far easier than playing around with notes and carrying cash and doing exact change, because Bhai has a lot of friends, and what they have done is create a whole lot of apps which allow you to pay for coins by using an app on your mobile phone, or just from Twitter, you can send a tweet to somebody and it transfers Bhai coins, or you can do it using SMS or other such things, right? So very soon the convenience, and of course some people also like the fact that they don't have to pay taxes on any transfers related to Bhai coins. So very soon Bhai coin is in demand, and people are more and more people want Bhai coin. Even people who are not Bhai's friends, they want to get in on the system, and soon there is a market setup where people are buying Bhai coin using rupees, and there is a fairly standard exchange rate for these coins, right? Uh, at some point, Vaishali starts accepting Bhai coin from its customers, and then an enterprising person in Surat sets up an online exchange where anybody can buy Bhai coins by paying rupees using credit cards or bank accounts, and of course NRIs can buy Bhai coin using dollars, right? And after a while, if ever in the system there is a situation where the exchange rate between Bhai coin and rupee, or Bhai coin and dollar, is a little out of whack, somebody is going to use arbitrage and make money on it. So soon there is a specific exchange rate set up for Bhai coin against the rupee and dollar, and they're all pretty much in sync with each other, right? So this is the situation. This is how a currency gets set up, and the only reason it works is because there are so many people willing to accept this money. And why are they accepting this money? Because it has some advantages over regular money. The advantages might be different for different people. For some people, it is ease of use. For other people, it is not having to pay taxes. For other people, this is something to do with privacy, and you don't need Aadhaar for Bhai coin, and anyway they hate government. But in any case, as long as there is demand, there is a value to Bitcoin, and that is how it has a particular exchange rate set up. Now, in all of this is being handled by a blockchain, and there are a whole bunch of servers, right? Why are these servers doing this? What is the incentive for the servers? So we have to figure out the commissions and the rewards. And as soon as we do that, we pretty much end up with Bitcoin. So I am going to jump to Bitcoin, which talks about such things. Let me just take a quick look at whether there are any questions here.
Yeah, so Naveen, this is Abhay here. So a naive question is that when it gets started, at that time you mentioned how people start using the Bitcoins instead of cash or whatever. What is how is the exchange rate set up at that time? That is not clear because it has to get started somewhere, right? How it is boosted?
Okay, so the question is, in the beginning, how does the exchange rate get set up? And the answer is that there is no real good answer. It is completely based on the initial adopters are adopting it not because it is useful, because in the beginning it is not useful. Until people start using it, it is not useful. But the initial adopters see a future potential. They believe that at some point this is going to be valuable, and they guess what the value should be. So this is kind of like, well, evaluating a startup or an IPO. You take a guess, and then based on that you are willing to pay some price, other people are willing to pay some price, and some guesswork happens and some price gets set up. Now over time, as the demand increases, the price will increase. If the initial people had guessed wrong and there is not enough demand, the price will crash and it will go down. So in the long term, actual usage will determine the price, but in the beginning, the price is pretty much random.
Okay.
There was another, yeah.
So there's just one more question, if I can, is from Atul Thomre. How do the exchanges convert paper currency with cryptocurrency?
Okay, so how does an exchange convert dollars into Bitcoin, right?
Naveen, you are muted, I think.
Yeah. What the exchange does is the following. It's an enterprising businessman. What this businessman does is that through whatever means, either by mining or by convincing somebody or by paying someone in cash, he manages to get a large number of Bitcoin in his own name. Now he goes and tells the whole world that I have an exchange. I can provide you with Bitcoin for rupees, and this is how much I charge. Now, whenever you pay him rupees which go into his bank account, and he gives you Bitcoin which show up under your name on the blockchain. Later on, when you want to cash out, what you do is you send him Bitcoin which are transferred to his name on the blockchain, and from his bank account, he sends you rupees on today's exchange rates. Yeah, Bhushan, you have a question?
Yeah, so you're essentially talking about the sovereign guarantee that every currency carries.
Yeah.
So it is totally based on the trust factor.
Yeah.
There is no real life equivalence of that, like you have the gold standard, which used to be there. Correct. For the sovereign guarantee and currency.
Yeah. So, right, a typical, 70, 80 years ago, most currencies of countries used to actually be backed by gold, where you said that if you own $1, if you have a note in your hand, it's a dollar bill, you can actually go and exchange it for a dollar's worth of gold. And they used to hold that much gold. It's a complicated system, but that is what it was. But they have given that up in any case. We have not had that kind of a guarantee since the 70s in any case. So yes, Bitcoin or any cryptocurrency doesn't have any such backing. It is completely based on the current demand of all the people. And if one day suddenly all the people decide that I'm not interested in Bitcoin, the price of Bitcoin will go to zero instantly. But today, that is true of the US dollar also. US dollar is only backed by the guarantee of the US government. Now, if for some reason US government suddenly loses credibility, the price of dollar will go in complete free fall. Yeah. Okay. You have a question?
Yes, sir. So why did the earlier cryptocurrencies fail?
There were no earlier cryptocurrencies. The Bitcoin, in some sense, is the first real cryptocurrency. There were earlier, okay, so there were earlier cryptocurrencies before Bitcoin, but the fundamental problem which is solved by the blockchain, which is a very complex interlocking system where completely random, untrusted servers need to be able to reach a consensus and then have an immutable record, unmodifiable record of transactions. And they need to be able to do it. They should get some incentive for doing it, right? So this whole system, which we talked about in the blockchain, was pretty much invented for Bitcoin. The earlier ones had one component of this missing, and that's why they didn't take off. Okay, Nitur, the question about incentives I'm going to cover now. So let's start looking at what is Bitcoin. Okay, hold on. Okay, so Bitcoin is one specific cryptocurrency, and it is a little more complicated than Bitcoin. In Bitcoin, we had created all the coins once in the beginning, but Bitcoin has a slightly different system. What it says is that 50 new coins are created every time a new block is added to the blockchain. And those 50 new coins go to the server which added the new block. Now, from the blockchain, you'll remember that every 10 minutes, a new block is added to the blockchain and a server is randomly picked to do this. So whichever server, it's sort of like a lottery, and whichever server wins that lottery gets those 50 Bitcoins. Now, the 50 Bitcoins, this is not a fixed number. In fact, every 4 years, this number becomes half. I'm sorry, there is a mistake on the slide here. It says it is halved every 4 years, and it has, over the 10 years of Bitcoin, it has halved twice. So these days, every new block that is created, the server that created that block gets 12 and a half Bitcoin. In addition, for every transaction inside that block, so there is one block which could have, say, 150 transactions. Every transaction typically has a transaction fee. So if I am transferring 10 Bitcoin to Bhushan, in reality, what will happen is that 9.95 Bitcoin go to Bhushan and 0.05 will go to the server which created this block. Now, the transaction fees are variable. Servers are free to charge whatever transaction fee they feel like based on their costs. And costs are based on how much electricity they are wasting on doing this mining business. So over time, the transaction fees go up. Now, the reason it was done like this is Satoshi, the person who created Bitcoin, he knew that in the beginning, there will not be enough value to Bitcoin. And so transaction fees, even if you charge hefty amounts, they'll still not be worth very much. So that is why in the beginning, this large number of Bitcoins were given as reward. And in those days, servers were doing transactions pretty much for free. But as Bitcoin got more popular and as the value increased, the cost of mining, the competition increased, because of which the cost of mining increased. And so server transaction fees will keep going up. And at the same time, the number of Bitcoins you keep getting will keep going down, so that by the year 2100 or something like that, there will be no new Bitcoin created. It's getting halved, right? So at some point, it just stops. Production of new Bitcoin stops. I think it's around 21 million Bitcoin. After that, no more Bitcoin will be created. So new blocks do not get any block rewards. At that time, servers are expected to make money purely based on transaction fees, right? Now, what are Bitcoin servers? These are the servers all over the world. Anybody can be a Bitcoin server. All you need to do is download the code for the Bitcoin software. This is open source, and you start running this software, and now you will be one of the servers in the network, and you have a chance of being picked. A fairly small chance, because there are like 13,000 servers, but you will have a chance of being the next block to be picked, and you will get all the transaction fees and all the reward, right? So this is the basic idea behind Bitcoin. Let me take a quick look at the questions. Yeah, so Raja asked, in my Bitcoin example, just initially some 10 million Bitcoins were created and no more created after that ever. That is correct. In Bitcoin, 100 are created every block initially, then it was 50, now it is 12.5, and it is going to keep going down. But this is just a design choice. There exist other cryptocurrencies. For example, Dogecoin is going to be creating new coins continuously and forever. That gives rise to slightly different kinds of economies. So it boils down to something similar, like Reserve Bank of India needs to decide whether to print new notes or not. Printing new notes is, I mean, economists will know more about this, but printing new notes, you do it too much and you will get inflation. But if you don't do it enough, and people keep holding, you get deflation, and people keep holding on to the notes, and then there is not enough activity in the economy. In real life, in countries, this is done by the central bank and the government. But one of the claims of cryptocurrencies is that they usually do this badly, and having an algorithm decided in a predetermined manner is actually a good thing. That is the fundamental idea behind most cryptocurrencies. Okay.
There is one question from Atul Thomre. Can I ask?
Yeah, go ahead.
Yeah. So he asks, what happens to the currency when the entire ecosystem goes down? That is, for example, Ethereum.
Yeah.
So what happens?
No, sorry. Yeah. I missed the question. Can you repeat?
Yeah. What happens to the currency when the entire ecosystem goes down? For example, Ethereum.
When the entire ecosystem what?
Goes down.
Okay. So I don't know what you mean by, for example, Ethereum. So let's move on to that. But basically, if the entire ecosystem goes down, the currency becomes useless, right? There are two different meanings of go down I could take here. One is that servers crashed, or all the servers are, overwhelmed with transactions and nobody is able to do anything. So for maybe 2 days, nothing is happening in the system. There are no new transactions happening. Then after 2 days, something happens and servers come back online, and then things are working. So for example, if you have heard of IOTA, this keeps happening in IOTA. It has happened a bunch of times. But they say, okay, well, this is just initial bugs. We are fixing them, and after that, everything will be fine. A different problem could be that everybody just gives up and goes away. Money is gone. Yeah.
Yeah. Thank you.
Okay. So what I'm going to do now is talk about some of the more advanced things that you can do with Bitcoin, because it is not just regular money. It is actually code in the cloud. You can do some funky things, and I want to give you a flavor of what is possible in Bitcoin. So advanced transactions using Bitcoin. Okay. Now, one of the things that I said was that a Bitcoin transaction is simply based on a signature, that the current owner has to sign a transfer, and that's it. But in reality, transactions can be more complex than that. In fact, they allow simple if then else kind of scripting. The default transaction says, allow this transaction to proceed if it is signed by Julie, because Julie is the current owner. But I can imagine a more complex transaction, which says that allow this transaction to proceed if signed by any two out of Julie and Neha and Karan. So if this, let's say there is 10 Bitcoin and it is attached, this is the code attached to it. What this means is that this 10 Bitcoin, the current owner isn't any one out of Julie or Neha or Karan, right? The current owner is a combination of these three, where any two of them are needed to spend this money. So next time when a transaction comes in and it wants to spend these particular 10 Bitcoin, it would need two transactions. So either Julie and Neha, Julie and Karan, or Neha and Karan. And there's just this simple if then else script. As long as there are two signatures, the transactions will be accepted. If two signatures aren't there, none of the Bitcoin servers are going to accept that transaction. Okay, so this makes sense, right?
Yes.
What I'm going to do is use this to implement an escrow service. Okay, now what is an escrow service? An escrow service is when, let's say, Julie wants to buy an expensive camera from Neha, and they are not in the same place, they're not in the same town. This is going to happen online. So what Julie wants is that Neha will send the camera over, and then Julie will send the money. Whereas what Neha wants is that Julie should send the money across and then she will send the camera. Neither of them is budging. So they use the services of Karan, who provides escrow. And in real life, without Bitcoin, the way you would do it is that Julie sends the money to Karan. Then Karan sends a message to Neha saying, I have received the money, you can send the camera. Then the camera goes to Julie. When Julie receives the camera, she checks it, she sees it is all good, and then she tells Karan, yes, I received the camera, you can release the money. And at that time, Karan sends the money to Neha and keeps a big cut for himself for providing this service. Right? If there was any conflict where Julie claims that she never received the camera or it was damaged, then Karan gets involved. He does an investigation. He figures out who's at fault. If it is Neha at fault, then he will return the money to Julie. If he decides that it is Julie at fault, then he will still give the money to Neha. This is how escrow works today, and Karan charges quite a lot of money for this service. What we can do with Bitcoin is simplify this. So when Julie wants the camera, without bothering to contact Karan, she knows that Karan provides escrow services. What she does is she creates a transaction with the full money to be paid to Neha, and she creates this 3 signature thing, saying that this money can be released only when signed by any two out of Julie, Neha, and Karan. As soon as this transaction appears on the blockchain, Neha can see it, and then Neha sends the camera across to Julie. Now what happens? If Julie receives the camera properly, she is happy, she signs a transaction, Neha also signs the transaction, and now Neha can withdraw the money. You're done. All of this happened without involving Karan at all. You just needed to put Karan's name, his public key, in that transaction. But as long as Julie and Neha were happy, which is 99% of the cases, Karan didn't even need to know that this transaction exists. But if there is a conflict between Julie and Neha, what happens is that now they involve Karan. Karan starts an investigation. If he decides that Julie was at fault, he will give his signature to Neha, where Karan plus Neha can sign and withdraw the money. If he decides that Neha was at fault, he will give his signature to Julie, and Julie gets to withdraw the money, right? The point is, and for doing this, Karan is going to charge some money. Okay, but notice that Karan needed to get involved in such a tiny fraction of the cases, and he didn't need to handle any money himself. So he can charge far less for escrow services. In general, you have made the world a more productive place, right? I'm going to check if there are any questions at this point about the escrow before moving on to the next interesting transaction. Any questions? Yeah, Bhushan.
So the no conflict, no fees thing is what works, is that you're saying that current charge doesn't charge anything for his name and signature to be used?
Correct. Because the marginal cost for current is nothing. He is going to make his money only out of the conflict cases, and in the no conflict case, there is no charge. Or if current does want to charge, current should be charging a very low amount because his involvement is negligible. Okay. All right. I will now move on to the next kind of cool transaction that Bitcoin enables, and this is called micropayments. Imagine there is a website which wants to charge per page. Okay, so there are customers, and customers don't want to pay like a $10 monthly fee because they have no idea how much they're going to use this website. Whereas if the website says just pay as you go, pay 0.01 microbitcoins per page, and that's it, right? The problem is that using credit cards and accounts and things like that today, nobody has managed to implement a system like this because it is too expensive. And in general, doing a transaction per page is very expensive. Of course, you could do this by keeping a running account, and you trust that the website will keep the running account properly. But that involves a high level of trust in that website, and people don't want to do that, as has been seen from history in the last so many years, right? Instead, Bitcoin has a solution through a mechanism called off-chain transactions, and I will explain what an off-chain transaction is on the next page, right? But basically, imagine the following setup. The customer pays 20 microbitcoin to the website. Think of this as a deposit. Okay, so now this 20 microbitcoin is on the blockchain as something that belongs to the website. But the website emails a refund transaction of that same 20 microbitcoin to the customer. Okay, this transaction, which is signed by the website, is not being put on the blockchain. This was just emailed to the customer. The customer has it in his pocket. If ever the customer puts it on the blockchain, this will be a valid transaction because it is signed by the website, right? So, in effect, at any point, customer can get back his money. But this is what happens. The customer reads one page, and at this point, the website emails a new transaction on the same original 20, which says pay out of this 20, pay 19.99 to the customer and 0.01 to the website. Again, this is emailed to the customer. The customer has this in his pocket. This also invalidates the previous transaction. And what happens is that at this point, the customer can put this on the blockchain, and it would be done, right? As in, customer has ended up paying 0.01 microbitcoin. And you keep repeating this. After every page, an updated transaction is created, which invalidates the previous transaction. And when you put it, the transaction just keeps going on. You're keeping a running tab without actually doing any transactions on the main blockchain. Later on, at some point, after a large number of pages have happened, customer has decided that they've had enough and they want to close out the account. At that time, the last transaction that was received by the customer takes that, puts it on the blockchain, and now 3.64 have gone to the website, 16.36 have come back to the customer, account is closed. Although there were a large number of email transactions that happened, only 2 blockchain transactions happened. And This is the power of microtransactions. Now, it was originally envisaged that Bitcoin will be used for this. But these days, the cost of even those two transactions has gone up so much. A typical Bitcoin transaction takes about $10 commission. So even doing those two is no longer feasible. But we will see later that. But one thing is that if it was some other cryptocurrency, not Bitcoin, but something else where the transaction fees were lower, then we could be doing this, which is pretty cool. And even for Bitcoin, we will see an example called Lightning Network, which takes this two steps further to make it feasible with Bitcoin itself, right? So, okay, so one question I see is, what is fundamentally different in this Julie Neha Karan Bitcoin-based transaction other than paying credit card, right? You pay by credit card, if happy, do nothing else. Otherwise, only when there is a conflict, then go through the whole, dispute mechanism. Where is the gain in efficiency, right? The trust seems to be same, whether it is current or Visa, MasterCard, Amex. The thing is that, to be frank, Visa, MasterCard, Amex are not in this particular business right now, right? If two random people want to do this, Visa is not going to be in the middle. Visa doesn't guarantee anything. Credit card transactions can be reversed by the end customers, and pretty much the merchant has to absorb the losses, right? The primary reason is that there is no real money in this system. Whatever money, whatever guarantees are coming from Visa, and if Visa doesn't have enough confidence in the end customer, which it often doesn't, then there's nothing that can be done, right? Whereas on the blockchain, there is real money sitting right there, which is definitely going to go to one of the parties, right? And this whole concept is called settlement risk. A large amount of the financial industry today is about how to deal with the settlement risk, and the people who are giving you those guarantees are charging money for it, or are doing it only for a few people. And of course, settlement risk, the kind of risks are needed in certain businesses, but there are a lot of businesses where you can get rid of it completely if you were able to do it with real money which is sitting there on the blockchain, and you know that it is going to go to this party or that party, right?
I mean, there is a question here from me, Abhay.
Yeah.
So in the micropayment case, that whenever that person, the website invalidates something and then gives they have to register with the blockchain, right? It is just that the reader is not encashing that, but so
see, the first transaction needs to be registered with the blockchain. All these intermediate things that are being sent, they don't need to be registered with the blockchain. Just there needs to be a transaction which is signed by the party, and at any point when this is put on the blockchain, it will be a valid transaction. So that's all. The one thing to note, right? When there is no such concept as registering with a blockchain, suppose Bhushan creates the way this works in a blockchain is that when you are giving money to somebody, there is no somebody in the blockchain. There are only public keys and private keys. And to send money to someone, you send it to a public key. And to spend it, or when they want to digitally sign a transaction related to that, they have to sign it using their private key. So if Bhushan sits at his computer and he creates a public key private key pair without being connected to the blockchain, right? Now I can create a transaction sending money to that particular public key, and now that's it. It's a valid transaction in the system, and that never needed to be any step where this particular public key or private key was registered with the blockchain. The thing is that anybody who can produce a signature for this particular public key can spend that money. If you can't, and the only person who can do that is the person with that private key. Now, it is possible that I send the money to something which is not a public key. Let's say I make a mistake in copying the public key. Now, there doesn't exist a private key which can extract this money. In that case, that money is lost. It is gone. Nobody will ever be able to spend that particular Bitcoin.
Yeah. So,
right. This is how it kind of works.
So maybe just once. So when you say the website invalidates the earlier transaction, they just change the passwords, like the keys.
No, actually, sort of. I messed up a little bit there. So what I will do is that part I will come back to a little later. But the thing is that it's a double spend, right? So there is a way in which only one of these transactions can go onto the system, and the next one can be invalidated.
Right.
I can't explain that clearly, but let me come back to this. I want to get through some of the other things, and then we'll look at that. Okay?
Okay, thank you.
All right, let me see if there is another question. All right, let me just move on to some of the issues with Bitcoin, right? Because Bitcoin itself, there are lots of possible problems, and there are overall some solutions coming in and some are still being thought about, right? So one question is that the code for Bitcoin and the protocol, can that ever be changed, or who is allowed to change it? It is one thing to say that Bitcoin code was once written by Satoshi 10 years ago and we will never change it, but that's silly. There can never be bug-free code. Plus, over time, you do realize that things need to change. So the way that works is that there are some bunch of guys, okay, influential people, let us say, in the Bitcoin community, and they have discussions on mailing lists where they say that we are going to make so and so change. Now they need to convince all the servers in the world that you need to upgrade your servers to use this new code. Okay, now if these guys, if the change is something sensible and everybody thinks we should be making this change, then fine, this change they put up on GitHub and everybody downloads that and they start using the new code and you manage to change the Bitcoin protocol. Once in a while, what happens is that the community cannot decide. Half the people are saying, no, we can't make this change, and the other half say we can make this change. And in that case, if they just can't reach a conclusion, what happens is that you end up with what is called a fork. So let's say half the people have downloaded the new code and half the people have the old code. And what will happen is that there are some blocks which are accepted by the new code, which won't be accepted by the old code. And there are blocks which are doing the reverse. So pretty much these two sets of servers are seeing completely different histories, right? So this has pretty much what has happened is that now you have two different currencies. And in real life, this happened like a year or two back when Bitcoin split into Bitcoin Classic and Bitcoin Cash. Okay, and anybody who owned Bitcoin before the fork now end up with the same number of Bitcoins in the new chain as well as in the old chain. So this is like a company stock split, right? So you now own stock in both the companies, but in reality, what is going to happen is that the value of both the companies is going to go down, and the total value that you got will be roughly same as what was before. And then what will happen is that these two will evolve independently as two different companies, and their valuations are different. And depending on which side the market likes more, one of them I mean, the values will essentially evolve independently. So in case of, say, what has happened is that Bitcoin Classic has gone up to, $13,000, $10,000, whereas Bitcoin Cash has stayed at a much lower value. Okay. Another problem is that size of a block. In the old Bitcoin code, the size of a block was fixed at 1 megabyte. You cannot have a block that is more than 1 megabyte, which means that you cannot create more than so many transactions in each block. And the way Bitcoin works is that you create one block every 10 minutes, which means that Bitcoin can only handle 200 transactions per 10 minutes. That's a ridiculously low number. And they couldn't decide how do we increase this, because some people said we should have much larger blocks, but others felt that that's a security problem. And there was no consensus. In fact, the splits happened because of that. Even now, there are 2 or 3 different solutions being considered for this. This is ongoing work. Okay, try to reduce the amount of data you have to store on the blockchain per transaction, or do transactions elsewhere, and so on, right? That's another problem. A third problem that everybody knows about and talks about is the fact that as the value of Bitcoin has gone up, the number of servers interested in getting the commissions and the rewards has gone up. And as the competition has gone up, the cost of running a Bitcoin node goes up, right? And so because of that, the commissions have gone up. $10 commission per transaction is very high compared to what the original idea of Bitcoin was. So all of these are problems, okay? And people are dealing with that. Some of those we will see a little later. The alternative coins are trying to handle these things. Now, just coming quickly to some specific things, right? Most people today can't get Bitcoin by just mining them. So you have to buy them on exchanges. And most countries in the world have now created KYC requirements. In India, the legal status is still unclear. RBI is still thinking about, what rules they're going to come up with for Bitcoin. It's expected to happen anytime soon. But right now, you can buy Bitcoin. There are about 10 plus exchanges in India. They will do full KYC with PAN and Aadhaar and everything. And then you transfer rupees to their account and they let you buy Bitcoin with that. When you sell Bitcoin, it's unclear what exactly happens, right? But at this point, it is believed that you should consider that as a capital gain and put it in your tax returns and pay tax on it. Just a couple of weeks back, the income tax department sent notices to a whole bunch of people because they did not pay tax on gains they got out of cryptocurrency transactions, right? There's one story I want to get into, which is related to Bitcoin anonymity, right? Because Bitcoins are owned by just these public key, private key pairs. So earlier, it was believed that a name doesn't have to be really associated with this. Even now, if you buy through an exchange, then they will attach a name to your public key because of the KYC requirements. But if you use a server to mine and you get Bitcoin, you're still totally free, right? And people used to think that Bitcoin is pretty much going to be used for drug dealing, for money laundering, and other such illegal things because of the anonymity it provides and be completely out of reach of the government. The thing that took a little while to realize, okay, is that Bitcoin is not anonymous. It is pseudonymous, which is that all transactions are tracked, all public keys are out there in the open, and when money moves, you can follow the entire chain backwards. So an example is that there was a website called Silk Road where all kinds of illegal stuff could be bought. and pay them using Bitcoin. Obviously, on Silk Road, you couldn't pay using credit card because it's illegal and you would be tracked. But Bitcoin was great. What the FBI did was they saw that when you buy things on Silk Road, where is that money going? Which Bitcoin address do you have to pay to? And then they just kept track of the money on that address. That money was later on used to pay for something else. That money was used to pay for something else. And you keep doing this. And at some point, somebody is going to use that money to buy something in real life. A car was bought using that money. FBI went, looked at got the car dealer and asked them, okay, who bought this car? And the car dealer knows it was delivered to somebody, right? And now you can follow the chain backwards and find out who is the person who owns Silk Road, or who at least getting that money. That person is in jail. And that's when this happened about 3 or 4 years ago. And that's when things flipped. Suddenly, I think both people as well as governments realized that it's not going to be that easy to use Bitcoin for illegal transactions. And that's when people started pouring more money into it. Government started taking it seriously. Financial institutions like NASDAQ, like all the top banks, started taking it seriously. However, what happened was that the people who had created Bitcoin, or at least some of the people in the cryptocurrency area, they felt that anonymity is an important thing. Being able to hide money transactions for the government is important, especially in repressive countries where dissidents need to be able to do this. So they have gone and invented other cryptocurrencies where they're not just pseudonymous, they're truly anonymous. So when you do a transaction, you can't follow the tracks of the transaction. So Monero and ZCash are two such cryptocurrencies where they use clever cryptographic tricks so that the money you have to pay to a particular address, right? But you don't just directly pay to that address. You use a cryptographic trick so that from that address, a new address is created. The original owner can extract that money without having to tie it back to his public key, right? And some of that cryptography is very interesting, but beyond the scope of today's talk. But you get private money. Now, that is a good thing for the good cases, but certainly a bad thing also, because I know of actual, say, pornographic rings in Sri Lanka are using Monero to run their operations, right? So it's tricky. The other few issues related to Bitcoin, I'm just going to quickly go through here. So one is the expense. The expense of running a server node, right? Everybody is making a big deal out of it, and it is a big deal that Bitcoin network overall is using more electricity than Denmark or something like that, right? The thing is that so far, if you remember from the blockchain talk, the work that is done as part of mining a new block is necessary to be able to give the guarantees that you can't change transactions afterwards. This bit is necessary. Okay, that creating new blocks or creating fake blocks, if you want to change the history, needs to be expensive, right? So can you do something about it? So one is that one problem is that people who can afford expensive CPUs, or people are actually using specific integrated chips, ICs, just to solve the Bitcoin problem, right? And those people now are getting most of the commissions, most of the new blocks. And anybody who can't afford to create their own ICs can't even get into the network. So people have created a different kind of puzzle that you have to solve. And that results says that you need to have a large amount of memory or something else, right? The idea overall being that creating a new block should be expensive, but it doesn't have to be expensive in terms of CPU. It can be expensive in terms of something else. And that's ongoing research. Another way it could be expensive but still useful is that instead of solving a random maths problem, how about doing some useful work? And some examples are, finding cancer genes or protein folding and things like that, SETI. One issue with all of this, though, is that if the problem isn't totally random, then somebody can figure out how to game it. And over time, they can figure out how to make a lot of money. So it's not something, people have not solved this part of that problem. A third way of doing it is that you want it to be expensive, why not use real money? And where do you get money from? Well, there is actual money. That is what you are doing. So instead of CPU power, you put shares of your money, the cryptocurrency that you are using, and you stake that on the blocks that you create, so that if ever somebody manages to prove that you created a fake block, you will actually lose the money that you had staked. But over time, if your block is accepted by everybody for a long time, then you get your money back. And this process repeats. This is called proof of stake. It will be much cheaper than doing proof of work in Bitcoin. And Ethereum, which is another important currency that we will, blockchain that we will cover later, is hoping to switch to a proof of stake system later in the year. The main thing is that these things, huge amount of money is involved, and tiny bugs can be used by someone to take a large amount of money. So it needs a lot of research and a lot of testing before anybody is going to accept it. So proof of stake is in that stage right now. Now, let me just quickly go through a couple of non-Bitcoin cryptocurrencies. Why do you have something other than Bitcoin? So one is, it could be exactly the same as Bitcoin, same code, same parameters, same everything, but a different set of servers, right? And that can be done. The question is that if it doesn't have any significant difference from Bitcoin, why would anybody bother, right? So those things usually don't work out very well. But another possibility is to have everything exactly same as Bitcoin, but slightly different parameters. So you could say that the number of coins is much larger. Or you could say that the blocks aren't created every 10 minutes, they're created every 2 minutes or something like that. And what all of that does is that it makes the coins cheaper, it makes the transactions cheaper. So Litecoin is one example where it is the same code as Bitcoin, but everything is cheaper and there are far more coins. So it can be used in places where this high transaction fee of Bitcoin is a problem. A third is that you could have a blockchain where you change some fundamental aspect of it, and that gives you a different kind of coin. So examples I gave related to privacy were Monero and ZCash. Another one I want to talk about, network. Okay, remember the micropayments idea I talked about? They said that let's generalize this idea. Okay, so instead of it being just one way, a customer paying a website, you can create a channel between two equal partners, say Julie and Neha, and both of them put 10 micro bitcoins in it. And now whenever Julie needs to pay Neha, and both signatures are needed to withdraw this money. So when Julie needs to pay Neha some money, you create a new transaction where that much money now is on Neha's part and the remaining is in Julie's part, and you create a transaction. And at the time of paying this money, both of them sign this transaction, but they don't put it on the Bitcoin. They just leave it in their pocket. And similarly, if Neha wants to pay Julie back, you create another transaction. And the thing that Abhay worried about earlier, which is that once I create a transaction where Neha has 11 and Julie has only 9, later on when you create a transaction, when money goes back, Neha could still put the earlier transaction into the system, and then the next transaction becomes invalid. So there are some fairly clever tricks which allow you to invalidate the older transaction when a new transaction comes. And the way that is done, Abhay, is that let's look at the example on the screen, right? In the first transaction, Julie paid 1.23 to Neha. So the pocket transaction that was created was, Neha now owns 11.23, Julie owns 8.77. Now when Neha needs to pay 1 back to Julie, she has to create a transaction where Neha now owns 10.23, Julie owns 9.77. Okay. In addition, she has to create an invalidating transaction which invalidates the previous one, right? The 11.23 transaction, there is a follow-up transaction to that saying that Julie can withdraw her entire 10 Bitcoin if this previous transaction ever shows up. Okay. So in the second instance, when Neha paid Julie, she gave 2 transactions. One transaction which is invalidating the previous one, and one new one which is reflecting the current balances. So at this point, Julie can just put the last transaction on the Bitcoin. Everybody agrees, everybody is happy. And at this point, then nothing else is needed because this transaction has gone into the chain. The previous transaction is automatically invalid. But if Julie keeps this in her pocket, the last transaction, she hasn't yet put it on the chain, and Neha puts the previous one on the chain, saying I have 11.23, right? Now that's a bad transaction. But immediately Julie can use her invalidating transaction and withdraw the $10 back, or entire $20. In fact, that's just to ensure that Neha will never put the invalid transaction onto the chain. Okay, so Abhay, I hope that answers the original question related to micropayments. I had unfortunately simplified a bit, but that's how it works. Let me see if there are any other questions.
Just quickly on the follow-up question on that. That means that the person, who, suppose somebody is dishonest and puts that transaction on that, the other person has to be alert to note that somebody has put that, so that they need to invalidate it immediately by doing it, right? So it's not. So it will not happen automatically.
Yes, that is correct. So if Neha puts the invalid transaction on the blockchain, Julie needs to keep a watch on that. Right now, the way Lightning Network works is that it also gives a time frame that Julie has so many days within which she has to put her invalidating transaction. After that, it expires. So that is one of the configuration parameters. But yes, it will not happen automatically. Julie has to be paying attention.
Right. Thank you.
Yeah. Now, let me just quickly complete what I was saying related to Lightning Network. This is the last, so we are almost at the end, by the way, so don't get unhappy. Lightning Network, what it showed was that you can create channels between pairs of people, but they go one step further. You can have lots of channels between lots of pairs. So I have a channel open with Bhushan, Bhushan has a channel open with Chinmay, Chinmay has a channel open with Abhay, right? Now, if I want to pay Abhay, what I do is I just tell the Lightning Network I want to pay Abhay, and Lightning Network looks in the blockchain, uses TCP/IP like routing, so that it realizes that if I pay Bhushan, Bhushan pays Chinmay, Chinmay pays Abhay, this can all work. And this entire series of transactions happens. All of them are pocket transactions, and they don't need to be put onto the blockchain until at some later point when settlement occurs. And here there is a little bit of trickery involved, because if I pay Bhushan and Bhushan refuses to pay Chinmay, then this chain is broken and Abhay is left in the cold. And there is a very neat trick to make this possible, which essentially involves that I don't pay Bhushan. I pay that Bhushan can get this money only with an extra password. And Bhushan pays Chinmay saying he can get this money only with this extra password. And Chinmay pays Abhay saying only with this extra password. And what is this extra password? This is an original password that Abhay had created and sent me, right? Saying that send me this payment using this password, so that if I pay Bhushan and Bhushan pays Chinmay, and when Abhay actually pays for the transaction with his pocket transaction, he has to reveal the password to Chinmay, and Chinmay, to claim his money from Bhushan, has to reveal the password to Bhushan, and then Bhushan gets the money, right? And there are other little minor things involved there, but basically that's the idea. The other thing to note here is that here you need to use your pocket transaction and put it on Bitcoin only when there is a dispute amongst any one of these parties. If there is no dispute, you can all be at this level. You can just be sending each other these things and never have to worry about it, and it'll just continue to work. And especially if there are a few central nodes who are sort of liquidity providers who are connected to large numbers of people, this thing will work very efficiently. So in fact, most of these, if you realize, there is no blockchain here at all, right? It's just point-to-point messages being sent. It is actually as efficient as the internet. So the scalability and throughput of this network would be incredibly high. But it is all layered on top of Bitcoin, and Bitcoin is the layer providing the guarantees in case of any settlement risks. Okay.
So Naveen, there is just one question from Atul Thomre. So he goes back to that example of invalidating transaction. So he's asking, will invalidating transaction attract transaction fee? Will it attract transaction fee?
Okay, the answer is yes. I mean, the question is that the invalidating transaction, will that also attract a transaction commission? And the answer is unfortunately yes. So when Neha makes a transaction to take away the money, right? The invalid transaction she puts on the blockchain, she ends up paying some commission, and then Julie, to extract that money, all that money, will end up paying another commission. So yeah, commissions are a bit of a problem in this. But see, the way this whole thing is used in Lightning Network is that these things are so cheap that commissions are fairly low, right? And it is also expected that having to go to the chain is going to be rare. So there is not going to be, in general, transaction fees shouldn't be an issue in this case. Okay, all right, let me see if there are any other questions, people. All right, thank you very much. You can ask me follow-up questions either on the YouTube YouTube video itself, or on WhatsApp or Facebook, and I will be able to answer those questions. Hopefully, we can put up some of those question answers as FAQs for other people also. Thank you very much. And let me just put up my contact info in case you need to contact me. There you go. This is information about the other talks in the series which are going yet to come: smart contracts, ICOs, permissioned blockchains, and just the more complex stuff. Contact info for me is up here. Get in touch with me. I'm happy to answer follow-up questions. Thank you very much, everybody, and good night. Good day.